I am going to talk about the second one a little more. So global warming stopped in 1998. That's a pretty specific statement. So you can look up the global temperature records, and I did. So this is the global surface temperature, land and ocean, corrected for all the problems with the global surface temperatures, from 1997 to 2010, actually to 2008 here. It's the mean average global surface temperature. So it goes up and it goes down. The global average temperature goes up and it goes down. Temperature is variable. In fact, any 1 year of temperature is not climate, it's weather. There's a big distinction, actually, between weather, which is what happens day to day or single year averages, and climate, which is the long-term average. But, so these are actually weather records we're looking at. But, so if you look at 98 and go to 2008, the trend is down. And 2008 was when this 1998 argument first really materialized. But this is cherry-picking data. This is classic cherry-picking of data on a lot of levels. So, for example, why not 97 to 2008? Or 99 to 2008? Okay, so the truth is 90 anything to 2000 anything is a subset of the data. So let's look a little more broadly. Oh, actually, before we do that, let's add the last 2 years of data, because 2009 and 2010 have occurred. Okay, so that's 2009 and 2010. So all of a sudden, 98 to 2010, 98 was a pretty warm year. It was actually, at the time, it was the hottest year on record, 98. And then for a couple of years, you know, global average temperatures had been a little bit lower. But 2010 is now the warmest year on record, or tied for the warmest year on record with 2005. Different temperature records vary very slightly, but they all show pretty much the same thing. But again, this decade, or 12-year period, is a subset. Why start with 98? This is the temperature record, global surface temperature record, from 1880 to 2010. And the little green line in the very top left, top right, that's the 12-year record that we were looking at a minute ago. So the decade, or the 12 years from 98 or 97 to 2010, is the warmest decade on record. So we're in a warming, accelerating warming period. But that's me, isn't it? Okay. But why stop there? We have temperature records going back 2,000 years. We actually have temperature records going back 900,000 years based on paleoclimate records, but I'm not going to show all of them. But this is the Paleoclimatic Reconstruction from the year 200 to the year 2010. And the little blue lines at the far right. All right, so the blue line is the instrumental record for the last probably quarter of a century. And you can see where we are. Not only is it the warmest decade, in a warming century, in a warming millennia. It's getting warm. And this is part of the reason why climate scientists are increasingly worried. So that's the issue of cherry picking. You have to be really aware. Cherry picking is a very common thing in any science. You have to be really careful that the data that you're being presented are all of the data. And even this isn't all of the data. So, surface warming, which is the data I've been showing you, is again only a piece of the puzzle. It turns out that most of the additional heat that the planet is absorbing because of more greenhouse gases in the atmosphere isn't going to surface warming. It's going into the oceans. The vast majority of it's going into the oceans. So you don't just want to look at surface warming. Even if he had been right, you have to look at more than just surface warming. You have to look at other things. Is there heat going into the oceans? A huge amount of heat's being absorbed by the oceans. A huge amount of heat turns out to be being absorbed by the ice caps and is being sublimated. It's going to turn ice into water. So there are a lot of other pieces of this puzzle. So being skeptical requires looking at all the data. Climate change is more than warming. We've just experienced the hottest decade on record. Ice sheets and glaciers are losing mass at an accelerating rate. Permafrost is receding. Intense rainfall events are increasing. Sea level rise is accelerating. Oceans are building up heat, which I just mentioned. Birds and butterflies are migrating earlier. Flowers are blooming earlier, and plants in general are photosynthesizing longer. If it was just temperature, and if our temperature records were crappy, you'd still have to explain all of these other things. You'd have to come up with an alternative hypothesis that deals with the physics that we understand, that deals with all of the observations, that deals with modeling and computer analysis. That's what science is about. You have to come up with an alternative hypothesis that explains those things. And those people who argue against human-induced climate change have never done that. Okay, so that's the key to skepticism. It's not enough to question. Science requires that alternative hypotheses be offered that satisfy these additional factors. Okay, another cherry-picking example. This year, in January, the president of the Heartland Institute, which is a group that initially was associated with the tobacco industry and now is associated with the climate denial industry, said national snow and ice data center records show conclusively that in April 2009, Arctic sea ice extent had indeed returned to and surpassed 1989 levels. We're not losing ice, he's saying. The ice records aren't saying that climate's changing, but in fact, the ice is just as healthy as it's been for 2 decades. Now, a skeptic would dig into that claim, and there are ways to do that. This is a great statement. Okay, which data records? National Snow and Ice Data Center records. The National Snow and Ice Data Center is the preeminent national snow and ice data center. It's the right place to go for data, which show conclusively that April 2009 sea ice extent has returned to and surpassed 89 levels. That's a pretty easy claim to check. Easy claim to check, yes. So I did. I went to the National Snow and Ice Data Center, got their data. These are the monthly data for 1989 in blue and 2009 in red, January through December. This is the data point. So just to remind you, April 2009 surpassed 1989. So not January, not February, not March, not May, June, July, August, September. So first of all, these graphs show ice in the Arctic comes and goes. It shrinks in the summer, it grows in the winter. So that's the curve you see. But these are the 2-year records. He had to look really, really hard to find the month in 2009 when the ice extent was greater than it was in 1989. That's cherry picking. If this was your bank account, you'd be pretty hard pressed to say that you had more money in 2009 than in 1989. But again, this isn't everything. So why just look at these 2 years? Why not look at all of the data that we have for Arctic ice extent? So this is from 1978 to 2010. Ice goes up and down. There's variability in this record, but you can see the trend. This is another reason why Arctic scientists are worried about climate change. In fact, climate change is going to be much more extreme in the northern latitudes than in the central latitudes because of the dynamics of the planet, of the atmosphere. But again, Arctic ice extent is only one measure. Ice extent is the area of ice. the extent of ice. But it's not the best measure of the heating of the atmosphere, because another factor is how thick that ice is. You could have ice of great extent and ice of exactly the same extent, but if one is a lot thinner than the other, you've lost volume. And that's a measure of heat absorption. So in fact, this is a graph for the same period. It's a little harder to read, but 78 to 2010. In fact, I downloaded this last night. This is the most recent data from May 2nd through May 2nd of 2011, showing the Arctic ice volume. Again, showing the very dramatic decrease in ice volume. This is where a lot of the heat's going. It's not going into warming the atmosphere. It's going into melting ice. So another argument, and I forget which number it is on the Skeptical Science website, is the atmosphere is not warming as much as it should based on what we understand about how much heat should be being absorbed by these greenhouse gases. Well, it's going into the oceans, it's going into melting ice, it's going into not just warming the temperature. So these are examples of cherry picking. They're subtle, they're difficult sometimes, but they're testable. Misuse of uncertainty. Should the public come to believe that the scientific issues are settled, their views about global warming will change accordingly. Therefore, you need to continue to make the lack of scientific certainty a primary issue in the debate. That's a quote from a Frank Luntz memo to the GOP congressional candidates published in 2002. Make the uncertainty the issue, not the science. And for those of you who remember the tobacco debate, this is exactly what happened. Make the uncertainty the issue. If the public believes the science is settled, they're going to move on to the policy questions. So let's make the uncertainty an issue. And Stephen Jay Gould said this best. Quote, in science, fact can only mean confirmed to such a degree that it would be perverse to withhold provisional assent. I suppose that apples might start to rise tomorrow, but the possibility does not merit equal time in physics classrooms. So there's a debate about fact, theory, the definitions of those things. We can argue about those things. Is global warming a fact? Is climate change a fact? Or is it a theory? Yes, all of those things. But there comes a point when the contrary arguments do not merit equal time, I would say either in our classrooms or in our state capitals and Washington. And there was a letter in Science magazine. I brought 40 copies of this, but for those of you, and I'll be happy to hand them out to those interested. There was a letter last May. It was the lead letter in Science magazine from 255 members of the National Academy of Sciences called Climate Change and the Integrity of Science, and it addresses this issue. How much time do I have?
You have about 5 more minutes before questions.
Okay. I'm going to read just one paragraph from this, but it's a great letter. You should take a look at it. There is compelling scientific evidence that our planet is about 4.5 billion years old, the theory of the origin of the Earth, that our universe was born from a single event about 14 billion years ago, the Big Bang theory, and that today's organisms evolved from ones living in the past, the theory of evolution. Even as these are overwhelmingly accepted by the scientific community, fame still awaits anyone who could show these theories to be wrong. Climate change now falls into this category. There is compelling, comprehensive, and consistent objective evidence that humans are changing the climate in ways that threaten our societies and the ecosystems on which we depend. The scientific consensus could be wrong, and that there is a better explanation. That's what Galileo, Pasteur, Darwin, and Einstein did. But when some conclusions have been thoroughly and deeply tested, questioned, and examined, they gain the status of, quote, well-established theories and are often spoken of as facts. So, a couple of quick comments about uncertainty. In 1986, the Surgeon General said, cigarette smoking is the chief single avoidable cause of death in our society and the most important public issue of our time. 1986, and this was frankly long after the science was clear to the scientists. So remember though, 1986. But then, in 1989, the Tobacco Industry Institute of Hong Kong said, the view that smoking causes specific diseases remains an opinion or a judgment and not an established scientific fact. And in 1996, the tobacco industry, which still existed at that time, do they still exist? I'm not sure. Quote, yeah, oh, we don't believe it's ever been established that smoking is the cause of disease. And the CEO of Philip Morris in 1996 testified, I think this was in front of Congress, I'm unclear in my own mind whether anyone dies of cigarette smoking diseases, cigarette smoking related diseases. Make uncertainty the debate and you can push off the policy questions for a long time. There are a whole series of issues about scientific policy misconduct, packing of advisory boards, imposing litmus tests, suppression of information is a tactic that's used, bullying of scientists, and Galileo is a classic example. And there's some recent ones against climate scientists. I won't go into these. I love this one quote, though. It's from Cardinal Bellarmine in the name of Pope Paul V in I forget the year, 1570 or something like that. Galileo is ordered to, quote, relinquish altogether the said opinion, namely that the sun is the center of the universe and immovable, and that the earth moves, nor henceforth to hold, teach, or defend it any way, either verbally and writing. Thou shalt not believe this. You know, you just can't relinquish the opinion. I love it for its clear nature. So, moving forward, scientists and the public should resist attempts to misuse science and to intimidate scientists who produce results not consistent with an ideology. But the scientific community also has to be aware of internal problems and fix them. The scientific community has problems. There are problems with peer review. There are problems with falsification of data. There are plenty of problems, and scientists love to find other scientists who make mistakes and call them out. But it's always a battle. Real skepticism, in the classic sense, should be encouraged. Scientists and scientific organizations must be able and willing to speak out against false skepticism, not real skepticism, but false skepticism and the abuse of science. Government and academic policies have to ensure the independence of science advising. We want our science advisors to be independent, to give advice based on science, not ideology. Funding needs to be transparent. I run a nonprofit research institute. All of our funders are listed on our website. Our 990s, which is our tax records, are public records on our website. Our independent audits are publicly transparent because we believe in transparency. Scientific results, however, ought to be independent of funding. And I have to say, the argument that so-and-so funded science, therefore it's bad, is not always a good argument. ExxonMobil funded this science, so it's bad science. That's not necessarily true. Funding ought to be transparent, but the results ought to be independent of the funding. And that's the key issue. And finally, the more we understand about logical fallacies, the better we're going to be able to argue logically, fairly, and productively, and move to what I think is the real debate, the debate about policy. Thank you very much. Yes.
Continuing, should the scientists in global climate change, for instance, be participating in the policy debate, and how?
Should scientists, specifically those in the climate debate, be participating in the policy debate? I believe very strongly the answer is yes, but I also believe that's a very personal decision. Some scientists are not good at that. Some don't like to do it. Some work for organizations where it's not encouraged. It varies. That's an individual's point. I think if scientists don't get involved in the policy debate, you don't get good policy. I also believe very strongly that scientists should be clear when they're talking about science and when they're talking about opinion. making that distinction helps make sure that you separate science from policy. But I also think scientists have opinions, and they should be allowed to express them, just to be clear, the distinction between science and policy. So I think yes. Yes, in the back.
Yes. First of all, Skeptical Science is also an app on the iPhone.
Yes, it does have a very good app.
The other thing is that the two scariest points of view that I see against the climate, with the climate denialists, and they're both contradictory views, are from the very religious. And one of them says that God won't let our climate burn up. The other one is that if we're getting warmer, God is doing it, and we shouldn't do anything to stop it. And what are people doing? I mean, that is just like a batshit crazy idea. I just don't know what we can do to counter that kind of mindset.
Okay, so the question is, how do we counter the piece of the climate skeptic or climate denial debate, which is basically religious-based? Either God won't let it happen, or it's God's will that it's happening. There is some of that, and there's some of that in Congress. There have been some remarkable statements recently from some congressmen saying climate change can't be real because God would never let it happen. I actually believe that's a pretty small part of the anti-climate debate. I don't know how to counter that one. That's a true ideological debate. But the biggest part of the debate is an ideological debate that I actually think is rooted in fear of government. If climate change is real, if humans are causing it, then, and if it's this global big problem and it's associated with our energy system and burning of fossil fuels, it's going to be difficult to deal with. And it's going to require not individual action, but it's going to require some government intervention. It's going to potentially require somebody to spend money, or maybe an increase in taxes or regulatory responses. That's what I mean. That's what I mean when I say there's a difficult policy debate about what to do about it. I think we're avoiding the policy debate because of some of those fears, and I think we have to tackle that one head on. Yeah.
My comment addresses what you just said earlier, that one of the problems that science has is a discipline. We're all guilty of it. That as good propagandists and good people at Madison Avenue know, that people become convinced of arguments, not by the logical inference of their forebrain, but by the limbic system of the brain, emotional arguments. So that's what, and we as scientists have not done a good job of it. Sit down and talk to us and we'll convince you. No, we're going to have to scare the hell out of you.
Yes, that's a great point. The issue is sometimes it isn't really, in the end, a scientific argument. It's an emotional argument. As a scientist, I understand that completely, but I don't actually know how to deal with it, to be fair. I'm logical. When I sit down at a conference next to a climate skeptic, what they call climate skeptics or a climate denier, I try to logically argue with them and present the science. And the truth is, often it's not really about the science. And sometimes I can change minds one-on-one, but often it's not really about the science. And that's a difficult question. And I don't want to get into a situation where I'm arguing from fear. I think climate change, if we don't deal with it, it's going to get worse and worse, and in the long run be really bad. I think we're screwing around with a dangerous thing here. But it's going to be decades before really bad things are really obvious, although maybe not that long. But I don't want to argue from fear. So that's a hard one for me. This side, yeah.
Another practical reason why I don't want to argue from fear, because the environmental movement's done it for 40 years. All these species are going to go extinct. People eventually get immune to this. They get immune to it. And when the really bad crap happens, it isn't necessarily going to affect them directly. So I think arguing with fear, you can cut your own knees off.
It was just a comment that arguing from fear is not an effective thing. I agree, but just to get back to this, there is going to have to be there is emotional content here. There are emotional issues. There are serious risk issues. So that's going to have to be dealt with. Sir?
It seems to me that the scientists aren't addressing the whole policy debate either. Because I first heard this debate in '95 between two people who absolutely believed that there was a problem. One was an economist, the other was a physical scientist. The economist seemed to have totally lost any public visibility on this. He argued that what we needed was not controlling the CO2, but ameliorated, getting away from the shore so when the sea rose, people laugh. But this is
Okay, so that's a great point. In my talk, I talked a little bit about this long spectrum, from the people who just don't believe it's happening to the people who believe it's happening and are trying to figure out what to do about it, maybe. On this side, sort of, yes, it's happening. Yes, humans are responsible for some fraction of it, maybe a big fraction of it. Is it going to be bad? Is it going to be expensive to reduce greenhouse gases? That's the mitigation question. Versus, is it going to be more expensive to have to pay for adaptation? Not mitigate greenhouse gases, not fix our fossil fuel problem, but simply adapt to climate change over time. That's a science and a policy question. And the science component increasingly falls in the area of economics, which is how do we evaluate the cost of mitigation versus the cost, very difficult to measure costs of adaptation. What's the cost of, what's the value or price or cost of species extinction? What's the cost of simply moving away from the coasts and letting coastal communities adapt? What are the costs of reducing greenhouse gases by getting rid of all fossil fuels quickly versus phasing them out over time? They're difficult economic questions, and frankly, the economists have not quite stepped up, in my opinion, to answering some of those questions yet. I agree with that. Sir?
An argument from authority that's very interesting is the U.S. Navy. And I heard an interview on NPR a month ago with a very high-level official in the U.S. Navy, and they are absolutely planning for drastic changes in oceans and sea levels in the next 30, 50 years.
Yes.
And they have had their discussion and they've reached the conclusion.
The argument is the U.S. Navy has made a decision to consider climate change a real issue. It's an argument from authority in a sense. I've worked quite a bit at the federal level with military and intelligence groups. Without a doubt, not just the Navy, but the military establishment and the intelligence establishment understands the risks of climate change. Their job is to evaluate threat. From a purely non-ideological point of view, their job is to protect the United States from external threats. And they're willing, and they've been willing for a long time, to consider anything a threat if the science suggests it might be a problem and to work on evaluating it. The Navy especially, Arctic ice is disappearing. The Northwest Passage was opened for the first time this decade and has been opened twice this decade. And all of a sudden, the Canadians and the Russians are building ships to operate in the Arctic to look for minerals and ironically fossil fuels and to think about new passages and economic strategies in the new open Arctic. So there are real geopolitical issues that the military is looking at. And I think it's an example of yes, the acceptance of the science from a non-ideological point of view just to try and understand what the threats are.
Will you be making this presentation available for download anywhere?
Okay, I will put a PDF of my slides on the Pacific Institute's website. So packins.org, where all of our publications are actually downloadable for free. And I'll figure out, it'll either be on the publications page or it'll be easy to find.
Thank you.
Yeah.
Hey, the favorite quote from Hume that politicians like is, reason is and ought to be the slave of the passions, because that's how they run elections, and that's how most people vote. Another point, the notion of possibility is always a good one, because when people say it's possibly not true, therefore it's not, and say it's possibly true. And so now what we're left with is the evidence. Possibilities cancel out. And the same thing is true with certainty.
Yes, so the issue is the argument that possibly this isn't true is countered by the argument that possibly it is true. And that's a good point. there's another piece to this, which is evaluating the relative risk and how we feel about risk and how averse we are to different kinds of risk. Another argument, and I forget which number it is on the skeptical science page, is that it's not going to be that bad. So there are uncertainties associated with all of these things. I didn't show you the uncertainty bars, and this is, from a scientific point of view, bad, with the paleoclimate record, the temperature record for the last 2,000 years. There are uncertainty bars, and the farther back you go, the greater the uncertainty bars, because we're recreating the temperature records. But one of the arguments is, well, there's a possibility it's just not going to be that bad. The counter possibility is that it's going to be worse than we expect. And climate scientists typically talk about the best estimate, or the average, or the mean. And so when the climate, somebody says it's, but look at your uncertainty here. Might not be that bad, it might not be that expensive. There's the other side of that as well. The other argument about risk aversion is my house going to burn down? I don't think so. The statistics are pretty unlikely. But I have fire insurance. I'm willing to spend money now to avoid a possible low probability but high consequence event, or to insure myself against it. And I think that argument's a compelling one. Sorry, one more question. I'm sorry, you've been great. And there are a lot of questions and I'm not going to be able to get to them all. But I'm going to be here. I don't have to go to a ping pong tournament. So I'll be here for a while.
I have a curiosity. The slide that was on the Paleoclimatic Reconstruction. I was wondering what method of Paleoclimatic Reconstruction you use specifically.
Okay. The sources are here. Paleoclimatic science is a very complicated science. The way we look at, there were no temperature records past 100 or 150 years ago. So how do we know what the temperatures were? The whole field of paleoclimatic reconstructions is a fascinating one, and it's based on pollen records and tree rings and ice cores and sediment records in oceans and under lakes. They're really all sorts of remarkable tools for reconstructing temperature and precipitation records from ancient times. They're records going back, I said, 900,000 years now. We drill ice cores in Antarctica. Every year in Antarctica, it snows, and it doesn't melt. And so every year there's a little bit of layered ice added to the ice record. And in certain parts of Antarctica, those layers go back 900,000 or a million years. And when we drill those cores, each layer has air bubbles. And in those air bubbles is ancient air trapped in the year that it was laid down. And with isotopic techniques, we can actually calculate the carbon dioxide concentrations and the temperature records based on the oxygen ratios. I mean, I could go on and on. There are lots of different tools. And there's uncertainty associated with each of them, and they vary. Some of them are available for some regions, others for other regions. But it's a wonderful field. It's an uncertain one. There's variability. That's why there ought to be error bars on this. This is, from a scientific point of view, this is bad. There are error bars. But that's the way they do it.
Was there a specific one? Because I know the different types, like the pollen records and 700 species.
Is this from one of them?
Yeah, is there a method in particular for this one?
This is a combination of paleoclimatic reconstructions using a variety of methods from a lot of different regions, in this case around the northern hemisphere, which is the majority of the land area. Thank you very much.